Okay, so we're now up to question 5. In question 5 again we've got I and j being our east and north vectors. We've got a ball that starts off being kicked at t equals 0, so we've got a position vector for the start and a velocity here. So it's a constant velocity in two different directions. First part of the question we're asked to find the speed of the ball, so we're going to take our velocity, because speed is just the length or size of velocity. So our 5a plus 8j, this is a, 5i plus 8j, so we've got that, and all we want to know is the length of that. So this is done by doing the speed square root of 5 squared plus 8 squared, which gives us square root 25 plus 64, which gives us square root 89. If we wanted to, we could turn this into a decimal using our calculator, but we're not required to yet, so we'll leave it how it is. For the second part of the question, we're asked to find the position vector of the ball after t seconds. So this is any amount of time we want, and we notice back in the question this is in meters per second, we're after time seconds, so we've got this position plus however many of these we want. So in this case we're going to have t lots of this. So if t was 5, we'd want 5 lots of this. If t was 7, we'd want 7 lots of this. So for b, we're going to write down 2i plus j, which is our initial position, plus we're now going to have our 5i plus 8j, which is our velocity, but we're going to have t lots of all of this. So you can write it out like that. We can then simplify it if we want. So we have 2 plus 5t i's plus 1 plus 8t j's. We'll call this S for position. So there's our answer for part B. All we've done is taken the two bits from here and simplified it into that, and remembering that's a 1j, even though it's just by itself. For part C, we're given this position vector B, and we're asked to find the time when the ball is due north of B. If it's due north, that must mean it has the same east, which is I, component as this, but a bigger north component. So we know that P, we'll call it P, has to be 10i plus kj, where k is greater than 7. Just put that there as a reminder to me there. So this is the same, so we've got this one here and this one here. They share the same east-west component. We don't know what this component is, but we know it's due north because it's bigger than this. So all we want to know is when our position here equals this. So we're going to put our 2 plus 5t I plus 1 plus 8t j equal to 10i plus kj. All we're going to do now is make our vector equations. We've got i's and j's and t's in all of these equations. We know that it must be the same I for all of them and the same t for all of them. We can build ourselves an I equation. 2 plus 5t equals, where are the other i's, 10, and a j equation, so this is 1 plus 8t equals k, because we've got k lots of j here. Solving the first one, we get 5t equals 8, by subtracting the 2, get t is 8 over 5, and using this result and this one, we get, sorry, I'll move it up. We get 1 plus 8 times 8 over 5 equals k. 1 plus, this is going to give us 64 over 5 equals k. Gives us k equals 69 over 5. Again, if we were asked for a decimal, we could turn this into a decimal, but we'll leave it how it is for now. We were asked to find the time when point B is the particle is above point B. So this is actually the answer that we needed for part C. This bit is going to be useful later on, so it's okay to work it out now. So we know that our actual point for point P is 10I plus 69/5j. So this wasn't actually required for part C. We should have just stopped when we got to here, which is our time, but we might need this later on. If we now have a look at part D of the question, we're given at time t equals 0, another player starts running due north from B and moves with a constant speed v. He intercepts the ball, that means he must get to the ball at the same time the ball is there. And we want to find the value of v. So this means he needs to be at point P at exactly the same time required. So thankfully we actually found point P here as part of our working for C. We didn't have to, we could have done it afterwards, but we've got this. We also know that B, this is 10I plus 7j. So all we need to do now is work out the distance. Which is the square root of 10I minus 10I and 69/5 minus 7 squared. So this is just the formula for distance between two position vectors. This gives us 0 here, and this gives us, if we do 69/5, let's get a calculator for this. 69/5, and then we're going to take away our 7, which gives us 34/5. So this is the square root of 34/5 squared, which is of course just 34/5. So this is our distance. We also know we've got a time, which is 8/5. So all we're asked for to find is the velocity or speed. So v equals, we've got a distance, we've got a time, so it's 34/5 divided by 8/5, which is 34/8, which is 17/4 ms to the minus 1, because it's speed. So that is the end of this question.